let us start the video right away today. Today I'm just going to be doing Advent of Code Day 12. Advent of Code is basically this challenge lasts through December where Eric Wastl releases 2 programming puzzles every day, and I'm going to be doing every single one of them and making video solutions for all of them. So today we're going to be doing Day 12, Rain Risk. Your ferry made decent progress towards the island, but the storm came in faster than anyone expected. The ferry needs to take evasive actions. Unfortunately, the ship's navigation computer seems to be malfunctioning. Rather than giving a route directly to safety, it produced extremely circuitous instructions. When the captain uses the PA system to ask if anyone can help, you quickly volunteer. The navigation instructions, your puzzle input, consists of a sequence of single-character actions paired with integer input values. After staring at them for a few minutes, you work out exactly what they probably mean. Okay. N means to move north by the given value. S means to move south by the given value. E means to move east by the given value. W means move west by the given value. L means to turn left by the given number of degrees. R means to turn right by the given number of degrees. F means to move forward by the value given in the direction the ship is currently facing. Okay. The ship starts by facing east. Only the L and R actions change the direction the ship is facing. Okay. We're given an example. We're shown how to do it. Okay, at the end of these instructions, the ship's Manhattan distance from its starting position is 25. Figure out where the navigation instructions lead. What is the Manhattan distance between that location and the ship's starting position? Okay, so today's puzzle doesn't seem too difficult. At least part 1 doesn't. We all know that part 2 might be bit more challenging. So yeah, we're just going to be doing the puzzle, and then I'll explain the solution. Okay, so we have arrived at our first answer, which is 1631. That is correct. Okay, so let me explain. I think this problem shouldn't be too difficult. Not too many of you should find this too difficult, I think, but basically we're just doing a simulation. We are given a set of instructions. Each instruction tells us how to move our ship around. North, south, east, and west. We just have to, I guess actually first I should explain what each set of variables be. So I just made a function that counts how that returns the displacement given the instructions. So displacement just means how far you move in the x direction and how far you move in the y direction. So we need 2 variables to store that. And then we also have a direction variable, which is which direction the ship is facing. So it starts out facing east, and that's 0. We're using like the complex plane stuff, like convention. So 0 is east, 90 is north, 180 is west, 270 is south. So we're using that convention. And then our displacement just starts at 0 for both x and y. So then we loop through the instructions. North, south, east, and west just means moving in a particular direction by a particular amount. So I made this dictionary over here, or a map, I guess you could call it. North just means 0, 1, because that symbolizes no movement in the x direction, but positive movement in the y direction. South is no movement in the x direction, but negative movement in the y direction. East is positive movement in the x direction, but no movement in the y direction. And west, you just follow that. Okay, and then after that, so north, south, east, and west are pretty easy to handle. After that, we have left and right. We just change our direction by the prescribed amount. So if it's left, that's a positive. That's an increase, and if it's right, then it's negative because we're using counterclockwise. Is increasing. We also want to take this mod 360 just to make sure that it's always stays positive. So because if we're doing it right, then we're subtracting, but we don't want to go negative. And if we're going above 360, we want to take that back. We want to loop that around. So like 361 would be 1. Otherwise, we assume that the direction is always going to be a multiple of 90, because that just makes the problem a lot easier and you don't have to deal with trigonometry. And I don't think you have to, because everything here is an integer. So yeah, this else is just if it's not north, east, or south, east, or west. and it's not left or right, so this means it has to move forward. So we're just looking at the directions. If it's 0, it means move east, 90 north, 180 west, 270 south. After that, we just have our total displacement in the x and y directions, and then we just perform that on the input. So that's basically it for part 1. Okay, let's move on to part 2. Before you can give the destination to the captain, you realize that the actual actions meanings were printed on the back of the instructions the whole time. Almost all the actions indicate how to move a waypoint, which is relative to the ship's position. Action N means to move the waypoint north, blah blah blah. L means to rotate the waypoint around the ship left, and R means to rotate the waypoint right. Okay. Okay. Okay, and F means to move forward to the waypoint a number of times equal to the given value. Okay, the waypoint starts 10 units east and 1 unit north relative to the ship. The waypoint is relative to the ship, that is, if the ship moves, the waypoint moves with it. For example, using the same instructions as above, F10 moves the ship. Okay, so it gives the examples. After these operations, the ship's Manhattan distance from its starting position is 286. Figure out where does the navigation instructions actually lead. What is the Manhattan distance between between that location and the ship's starting position? Okay, so let's just solve it and then explain. Okay, so we have arrived at our second answer, which is 86046. I don't know if that's right. Okay, that's not the right answer. It's too high. Okay, so I guess we should. I'm just gonna debug this, figure out where I went wrong, use the sample input, I guess. Okay, so we got another answer. It is 58606. I don't know if this is higher. Okay, it's the right answer. Great. So I suppose I should explain how we did that. Okay, so this one is a little bit trickier. So you're not just having a ship, but you also have a waypoint. So we need to store the location of the waypoint, which starts at 10-1, and then the location of the ship, which is 0-0, obviously. And the location of the waypoint is relative to the ship, but yeah. So now we have different types of instructions. We still have north, south, east, or west, except this time that controls the waypoint instead of the ship. So we can just increment and decrement that as we want. Like the first part, we just have a dictionary or map with the directions that symbolize the directions in like pairs, and then we multiply that by the amount to determine how far we should move the waypoint. After that, we also have left and right, and this means to rotate the waypoint. And this is actually a little bit trickier, so I actually want to pull up a OneNote page just so I can diagram this. Okay, so we have our ship at 0-0. This is our ship. And then we also have our waypoint. Let's just say it's at 10-1, for example. And I guess we should also draw the coordinate axes. And this is relative to our ship, of course, because rotation is also relative to our ship. So we have this line to our waypoint. This is just for reference. And this distance is 10, and this distance is 1. And I suppose I should erase that, but I won't. So first thing to note is that left 90 and right 270 mean the same thing. Left 180 and right 180 mean the same thing. And left 270 and right 90 mean the same thing. So let's just consider, for example, left 90, which is the same as right 270. So this is a 90-degree rotation because we're supposed to rotate the waypoint, suppose 90 degrees left from its current position. And if we just think about it for a bit, we see that this distance is 1 and this distance is 10 because we're kind of moving the triangle. So this triangle becomes this triangle over here, and I will erase that. So this triangle becomes that triangle over there. And we see that the new waypoint x position is equal to the original waypoint y position times -1. So this is the coordinate, x coordinate is -1 after the rotation, and the new y position is going to be just the original x position because that's 10. So I suppose I should put a prime after this to denote that has changed. But basically, if you think about this for a bit and you draw it out, we find that a rotation left by 90 degrees is the same as swapping the x and y coordinates of the waypoints, and then multiplying the coordinate of the coordinate by -1. And if it's rotating right by 90 degrees, then we swap them again, except this time we flip the sign of the y coordinate. And we just get this by drawing it out. You can try it out for yourself. And if the direction is 180, then we basically just reflect it over. It's kind of like turning all the way around, doing a 180, and multiplying each of them by -1. So that's left and right, rotating the waypoint around the ship. Otherwise, we have a F value, and I actually didn't read this correctly the first time. This means to move forward to the waypoint a total number of times equal to the given value. So this doesn't actually mean you move towards the waypoint. It means that you change the ship's x and y coordinates by the waypoint's coordinates amount times. So we have to do a change in x that's equal to the waypoint x times amount, and a change in y that's equal to the waypoint y times amount. So, for example, this example does it pretty well. F10 moves the ship towards the waypoint 10 times. So that's 100 units east and 10 units north, because the original coordinate of the waypoint was 10 units east and 1 unit north. So we have to multiply it by 10. And that's basically what we do over here if the action is forward. At the end, our ship has moved to some other location, and we just have that here, which is returned at the end, and then we do the same thing as before to parse the input and then print it out. So that's it for Advent of Code Day 12. I hope that was clear. I'm going to be posting the code to GitHub as well. Why don't we just do that right now? Okay, so it's pushed to GitHub. You can access it at the link in the description. As well, I will have a playlist in the description with all past and future days if you want to check that out, as well as a link to today's puzzles, of course. So yeah, that looks pretty cool. That's it for day 12. Also, just a remark, looking at this map, it definitely looks like we're going to be traveling back and forth a little bit, because it looks like there's an island over here, and day 13 is before day 12, which is pretty weird. And I'm guessing that maybe we're going to have to go back quite a bit to fill in these gaps over here. So yeah, that's pretty much for it for this video. If you have any feedback, feel free to leave it in the comments or DM me on Discord. My tag is in the description. So yeah, feedback is always appreciated. I always want to keep improving. Want to make these explanations as good as possible. Also, I'm trying to reach 400 subscribers by the end of the year. I think that's totally doable with these Advent of Code videos doing quite well, actually. So thanks y'all for the support. And the Use the Code videos coming out pretty soon, because the contest is coming out pretty soon. But that depends if I do the contest well. So that depends, I guess. But yeah, please consider subscribing if you want to see more videos. Let's get to 400 by the end of the year. So thanks for watching. I'll see you tomorrow. Goodbye.